Welcome to video number 4 of local projection method in Stata. This is the last video of the series, so please make sure that you have watched all the previous tutorials. Also, remember that in the description of the video, I have provided you with a link so you can buy the material to replicate the content. If you're passionate about understanding data and the economy, you are in the right place. Before we start with today's tutorial, I would like to invite you to hit that subscribe button. It's free and it really helps the channel grow and reach more people like you. If you remember in the first video, I've shown you what was the general formula to compute impulse response functions using the local projection method. Now I have replaced in that formula the equation with the name of our variables. We have in the dependent variable the log of non-farm payroll employment. We have a constant, the federal fund rate shock that we estimated and extracted in the previous tutorial. We have two lags of the dependent variable, and then we have two lags of a vector of control variables. So set T contains all the explanatory variables in our model. Finally, we have an error term that we are going to be computing using the new West, as I have mentioned in the first video. We need to ensure that we are correcting for autocorrelation and heteroskedasticity. The impulse response functions is obtained from 25 separate regressions, one per horizon. So we are going to be estimating this regression 25 times using OLS. And we are going to repeat this process for each of the variables in the model. By the end of the tutorial, you're going to be able to produce the impulse response functions like these ones using the local projection method. We are now in Stata and we're going to see how we're going to compute the impulse response functions using the local projection method. First, from the last tutorial, I forgot to save the dataset with the shock. So I'm going to call this Evan Marshall with shock. All I'm going to do then is incorporate the shock into our dataset. Now I'm going to teach you how we're going to use the local projection package. The command is local projection, then we have the dependent variable, and we need to specify which is the shock. Remember that we call the shock federal fund underscore shock. Then we can specify how many lags we want to use of the dependent variables. The command is y lags. In parentheses, I'm going to specify 2 lags. Then I'm going to include 2 lags of the shock. The command is s lags, and in parentheses, I'm going to type 2. Next, using 3 forward slashes, I'm going to go into the next line and I'm going to include the control variables. The command is controls, and in parentheses, we're going to type all the control variables. So we're going to include all the variables that we had in our model, and we're going to include 2 lags. The command is L for lags. We specify how many lags we want to include, and dot and the name of our variable. I have now included all the control variables in the model. I'm going to show you a couple of options that I like to include in the local projection. First, the number of horizons from 0 to 24, then the estimation method, which, as I mentioned in previous tutorials, I'm going to be using the new West. Next, something that we normally need to do with the new West estimator is that we need to specify a fixed number of lags for the heteroskedasticity and autocorrelation correction. So I'm going to be using the option that is called lag. So I'm putting here the option in brackets, and basically what it's going to do is it's going to tell the bandwidth to increase with the horizon h. That's all that we are doing here. Next, I'm going to type 0, which forces the impulse response at horizon 0 to equal 0. We're going to continue with saving this IRF. I'm going to type save IRF, and I'm going to use a name. In this particular case, I'm going to use the name LP underscore EM. I think this is everything for now. I'm going to add 3 forward slashes, and I guess we can add a title to our graph. I'm going to show you now how this is going to look like. So let's put, for example, LP response to a federal fund rate shock. So let's take a look how now this graphic looks like. You can see in the screen the response of the non-farm payroll employment to a federal fund rate shock using the local projection method. Next, what you have to do is to repeat the process, but for all the other variables in the model. That is for P, commodity prices, federal fund rates, non-borrow reserves, and M2. As an example, let's just run this one again. Let's see how this looks like. And here you can see what happens with M2 when there is a positive shock of the federal fund rate shock. Next, something that we can do is we can put all the graphs together using the graph combine. So I'm going to select all my script and I'm going to compute now all the impulse response functions in the same graph. And this is what the impulse response functions look like using the local projection method. I put them now in the screen together so you can see how using the two methodologies we get two very similar impulse response functions. Another cool graph we can produce is we can overlay the bar impulse response functions with the impulse response functions from the local projection method. So I'm going to run all this script and we're going to produce a professional graph. Here we get the impulse response functions. In dark, we get the ones from the vector autoregressive model, and in blue, we get those by the local projection method. Now in the screen, I have put together the impulse response functions computed by Jordà in 2005 and those that we have just generated. You can see that these graphs look quite similar. To conclude with the tutorial, I would like to talk about some extensions. Most of the current literature focuses on state-dependent responses. Impulse responses can vary depending on the state of the economy, that is, whether they are in a recession or an expansion, as well as on conditions such as high or low unemployment and high or low inflation or debt. On my website, you can find a list of many different papers that apply state dependency. For those interested, on my premium YouTube channel, we are going to compute state-dependent effects based on an economy with low versus high unemployment. Recall that in the description of the video, I have included a link for you to be able to buy the complete material, the complete do file, to be able to replicate the content that we have seen in my videos. If you value the content of this video, please consider subscribing to the channel. It's free and it really helps me to keep creating more content. Also, don't forget to share your feedback in the comment section. Did you like the content? What would you like to see next? Let me know.